Hi guys, my name is Paiman Nejrabi and I'm going to be talking about my project ResPulse. It is a performance regression detection and explanation system. It was built for ResilientDB under the supervision of Professor Mohammed Sidogi. So the motivation for this project comes from a common issue in software systems. The code can compile, tests can be passed, and the application can still become slower after a change. This is called performance regression. In a distributed system such as ResilientDB, that problem becomes even harder because performance depends on many factors such as transaction latency, throughputs, continuous behavior, and workload conditions. So the problem I focused on was not just whether ResilientDB works, but whether it continues to perform well over time. Before ResPulse, there was not a clear automated workflow for running benchmarks, comparing results to historical baseline, and detecting regression and explaining them in a developer-friendly way. To address this problem, I built ResPulse, which is an automated performance regression monitoring tool for ResilientDB. The idea is to create repeatable workflow where benchmark tests are run against the system, important performance metrics are collected, and the current results are compared against historical baselines. If ResPulse detects any latency has increased, throughput dropped, or success rate has changed beyond the set threshold, it flags that as a possible regression, and then the system generates AI assistant explanations to make the results easier for developers to understand. So instead of only just showing raw numbers, ResPulse tried to answer the three questions. What changed? How serious is the change? And what should the developers look into to improve this regression? The implementation stack that I've used for this project is the following. I use Bash for our testing engine and also Python to analyze our data and also connect to our DeepSeek API, which is used to generate AI explanations after each test is done. React.js, Node.js, NodeMiller, and cron jobs are all used for our website for the front end, back end to send alerts and also to schedule different tests. And MongoDB is our to-go choice for our database. I'll talk about a little bit about the core components of the project itself before going over a quick demo. The first layer of our project is our performance test engine, which is a bash-based script that uses curl's native timing capabilities to capture the following metrics such as the TCP connect time, server processing time, response transfer time, and end-to-end latency. The way our script works is that it connects to the transaction endpoint of ResilientDB and it commits about 100 transaction, and for each transaction we are connecting the following the mentioned metrics, and then everything is put into an array and being passed to our next layer. By writing this script, we're actually evaluating the raw performance of the API without going through any extra layers such as the SDK or any Python layers. So after our script is completed and we collected all the information that we needed, it is being passed to our next layer, which is our data analysis engine. And using those data and information that we collected from our script, we use that to compute the six core metrics per run, which is the total latency and the continuous time, the TCP connect time, the transfer time, the throughput, and the success rate. As you can see in the picture to the right, this is an example of JSON file that we will receive after a test is completely finished and it goes through our data analysis engine. You can see that it mentions how many transactions we actually completed, what was the success rate, what is the average throughput and average latency. Moreover, it actually gives you a little bit of more information about the statistical summaries that we have, such as the mean, median, standard deviation, P95, P99 percentiles for tail latency detection. And I believe these statistical summaries are really important, especially when you're comparing a current run to a baseline of the current run, and if you are comparing the current run to any of the baselines that you choose, and the users have the options to compare their runs against the historical baseline of last 24 hours, last week, last month, last 6 months, or all time. Finally, after all the metrics are calculated and it's saved in our database, the user has the option to compare their current run against one of the baselines that they chose. And if they want to do a comparison, they also have the option to say generate analysis. And by doing this, by clicking the generate analysis, the AI receives the current run matrix, which was a the JSON file that I showed you guys, and the baseline also has the JSON format matrix and a PBFT specific context. And in return, AI returns a human readable report, which includes what the root cause analysis is, the optimization suggestion, and any performance trend interpretation. So basically, and instead of just comparing the runs and showing raw numbers, actually interprets the raw numbers into a more user-friendly interpretation, or it explains to the user how the current run compared to the baseline that they chose, and if there was any regression, it'll give them a step guide of how to improve this and regression, and how to overcome any issues or any problems that they are facing in their system. And lastly, we have the option of scheduling and also allowing alerting system. For scheduling, we are using cron jobs, and for sending alerts, we're using NodeMailer, which sends you can send alerts to users by just putting in their email address, and the users have the option to schedule alerts or every hours, every week, month, or 6 months. And as you can see on the right side, once they want to schedule a test, they have the option of choosing between these options, and they can also enable alerting by just putting in their email address and choosing what metrics they want to keep track of. So as you can in the picture, it says latency 10%, but they have option to add more metrics, but they can add duplicate metrics. So it can be latency 10% and latency 20%, because that is not possible. But yeah, and it keeps track of these, and it runs the scheduled test every hour in this picture. And if there is any regression and if the latency has increased over 10%, they will receive an email letting them know that there was a regression detected in the system. And this is an example of an email someone would receive if there is a performance regression in the system. As you can see at the top section, it tells you that you set a threshold of 1% of the throughput has decreased by 1%, send us an email, and it did decrease by 99%. But so yeah, there is a regression detected in the system, and it gives you a timestamp of which test actually was flagged as regression. So it is kind of making it easier for the user to go back in the system and actually see what the explanation that was generated by the AI is, and what are the steps that they can take to improve this and overcome this regression. And also gives you a little bit of more information about the other metrics of that run that actually was flagged as regression. Now it's time for a quick demo, and I'll go ahead and open up the website, and I'll see you guys there. So once you open up the ResPulse website, you're given the following UI. At the top, you have the option of running the test all the way from here. From the UI, you can also refresh the page to see if there was any tests that are completed. It's not shown in the chart below, but I think the refresh functionality runs every 10 to 20 seconds automatically. I also have the option to schedule jobs and enable your alerts. We'll go ahead and start with that, because it takes a while for our scheduling to run and be completed. And once you press that, you're giving the following overlay. You choose how often you want to run your test. For testing purposes, I have it every minute, but by the time the website is live, this should be disabled. And it tells you what is the baseline that you want to compare your scheduled test to. as a default, it always chooses the baseline that has the most amount of runs, and also disables any baseline that has less than 3 runs. So for the last 24 hours, we don't have any runs, so it is not one of the options you can choose. We'll go ahead and choose 6 months. And if you want to enable your alerting system, you have to put in your email and ask you what metrics you want to keep track of. You can add more than one metrics, but you cannot add duplicated metrics, as I mentioned in the slides. We'll leave it as latency at 10% for now, and all you have to do is just say save configurations, and it update the UI and tells you that you have something scheduled every minute, and you are also enabling alerting system. And here it shows the top 4 metrics that we're keeping track of for the most recent run, which is the May 21st one. And at the bottom, these values shows how it compares to the baseline that we have selected. So if I go ahead and change it from 6 months to 1 week, you can see these values get updated. And in here, you can change the different baselines you want to view. 24 hours, we don't have any data, but we can keep it for 6 months for now. And you have the option to change the different on what is presented on the chart. You can see the continuous, throughput, or success rate. And the green dots mean it is normal, but the red line means that it could be an anomaly. At the bottom, you can see all the runs that we have in our database that is in the last 6 months. If you change it to 1 week, it also gets updated too. And I believe our scheduled test has been completed. Well, I'll go ahead and disable that so we don't have multiple test points now. And if you want to disable the scheduled runs, you can just go ahead and delete that, and it will disable it for you. Don't worry that this is all the way up here. I think the reason for this is because I had everything running locally when I was testing and building up the website, so everything was a little bit faster. But now I'm connected to actual live transaction endpoint. That's why the values all are a little bit didn't look a little bit abnormal. So if you click on one of the dots, it gives you information about the run. The first information you can see is that an explanation of what the test was. It tells you it was 100 transaction with 100% success rate. What was the throughput? What was the latency? What the P95 and 99 were, and also what was the continuous round trip average. And this is where the generate analysis, the AI explanation comes in. It says that we want to compare it to the last 6 months, and if you want to change that from last 6 months, you can do it to, all you have to do is change the baseline in here. If I do 3 months and click on that, it says generate analysis for the last compare it to the last 3 months. I'll leave it at 6 months for now. And if you press on that, it takes about 10 to 20 seconds to generate analysis and how it compares, how this run compares to the last 6 months. So I'll give it a little bit of, so the first thing you see is that it gives you an explanation of how it compares to the last 6 months that we chose. It tells you that the performance has gotten worse as the latency has increased by 4,000% and the throughput has dropped from 4,000 to 5.18. And this is obviously a regression, and it gives you a step-by-step course of action that you have to take you could take to improve and counter this regression. You have the option to also delete the test in case anything goes wrong, or there's a test was incompleted, or there was a connection error. So we'll go ahead and delete it for now, so our UI just looks a little bit more normal. And I think on the bottom you do see the run histories that as I mentioned before. And these are all the functionalities that I have implemented so far for ResPulse. Actually, as there was detection, as our test was that regression was detected and our latency did increase by more than 10%, we did receive an email. So I'll go ahead and show you the example email that I received. It is from ResilientDB monitor. So it tells you that, yeah, the latency did increase by 4,000%, and you set it the threshold at 10%. So this, we are sending you an alert, and this was the test that caused this regression. And here are some of the other metrics about this run. So you are receiving an alert if something goes wrong in the system, and of any of the scheduled tests are causing regression. So yeah, I think this is all that I have for the demo. I'll see you guys back on the slides. Right now, the current version of ResPulse just establishes the core workflow for detecting performance regression. In the future, if anybody is working on ResPulse, I have three features in mind that could make the system more automated and more intelligent and more flexible. The first one is the automated pull request testing. ResPulse could be integrated directly into pull request workflow. So every time a developer opens or updates a pull request, ResPulse could automatically run performance benchmark and compare it to historical baselines in our database. This would help us detect regressions before the code is merged and pushed into production. The next one is enhancing the AI analysis with multi-model comparison. So right now, as we saw in the demo, we only have the DeepSeek API to generate our AI explanation. So in the future, I think it'll be awesome to have multiple AI models such as ChatGPT, Claude, and Gemini, and get different explanations from them, and we can compare these explanations to one another. And I think this could make the explanation system more reliable by checking whether different models agree on the likely causes, severity, and severity of the regression, and whether they agree on the steps that we have to take to counter this regression. And finally, multi-configuration scheduling testing is the last feature that I think will be really nice. Right now, we can only schedule one test at a time. So as we saw the demo, we can schedule a test that run every hour and keeps track of latency. And if you want to schedule another test with different parameters, you'd have to delete this one and then set up that one. But I think in the future, if we can have a system where you can add different tests with different parameters, and it'll be really useful, because it will help developers track different parameters over different periods of time. And in conclusion, ResPulse was built to address the problem of silent performance regression in ResilientDB. A system can still pass all the functionality tests while becoming slower or less reliable. So performance has to be monitored over a period of time, not just checked once. ResPulse creates an automated workflow for running benchmark tests, collecting metrics that we need, and comparing our runs to historical baselines while detecting regression and generating AI assisted explanation for the regression that has been detected. The goal of the project is not to just show raw numbers, but also to make sense of these numbers and help developers understand what changed and what are the steps that they need to take in order to investigate the root cause of the problem. Overall, the project shows how performance monitoring can become more actionable by combining different aspects such as benchmarking, baseline comparison, regression detection, alert, and explanation into one system. And finally, I want to take this time to thank Professor Sadogi for his continuous support and mentorship throughout this project. I would also like to thank the members of the committee for their evaluation and consideration of this project. Thank you all.